Alright, here's the review for the test on Friday, which is actually tomorrow, the 2nd, February 2nd, because today is the 1st. We are going to first draw the inverse of the following functions and list the domain and range of the inverse function. Alright, so for the domain and range of my original function here, this function right here is the square root of x. This is our parent function for the square root function. My domain, our domain, we're going to list from the smallest to the biggest. My domain x, my range will be y. So for my function given, my domain, my x values, start at 0. So we say we include 0. And the arrow says it goes on forever and goes to infinity. So that's 0 to infinity. For range, we start at 0, it's our y values, so we go up, we hit 0, and then it's anything above 0, and this goes up to infinity in that direction. So it goes from 0 to infinity. The parent function for square root functions is always 0 to infinity. Now we're going to do the inverse. To do the inverse, we're going to pick points, and we're going to switch the x and the y. So let's start with 0, 0. Let's go 0, 0. Switch 0, 0. We stay at 0, 0. Well, that's good. Next point here is 1, 1. Well, 1, 1 switch is still 1, 1. After 1, 1, let's see. We have a good point right here. 4, 2. The opposite is 2, 4. Then over here we have 9, 3. So let's go to 3, 9. And we should have the inverse function like that. You should get a mirror image across this line right here. The y equals x. So that should be the same on both sides, and it is. Domain and range for this. That is going to be the same domain and range. It is still starting at 0 and going forever to the right and forever to the up. So my domain is still 0 to infinity, 0 to infinity. Number 2. Let's go ahead and start my domain for this one. My domain values, they don't start until we hit 2 here, not 2, 3. So it starts at 3 and goes, arrow says it goes to infinity. My range, on the other hand, I hit my arrow down here. That means it goes down forever. That means I'm going to start off at negative infinity. It's coming down here. And then it's going to stop here, and let's just call that 2. Say it goes all the way up to that point there. Now for my inverse, we're going to mirror that across that line in the center. So let's pick a point. So this point right here is 3, 2. The mirror of 3, 2 is 2, 3. This looks like a good point here. 4, 0. So we have 0, 4. Next point here looks close. 5, negative 1. So we have negative 1, 5. We got a good point here. 7, negative 2, so negative 2, 7. And I guess we can go at this point here. It's close. 9, negative 3, so negative 3, 9. So that's going to look like that. And again, that should look like a mirror image. Just like that. Looks the same on both sides. Looks good. Domain, x values. Well, the first x values that come across those arrows, that means it came from negative infinity, and stops at 2. Range values coming up. First thing we hit is 3. And it goes all the way up forever, which is infinity. I'll leave that one for y'all to do on y'all's own. Wouldn't be a good teacher if I didn't make y'all do any work. Alright, number 4, the graphs below show the function f of x equals the square root of x and function g as a transformation of f. For each graph, write g of x in terms of f of x. This is that one where we're going to actually use f of x instead of the actual function. So what is happening to this, which is, okay, I'm going to go out and highlight our parent function on each of these in red. So there's my parent function. There's f of x, square root of x. There's f of x. And what we're going to do is figure out what my transformations are. So first, let's look at this one. I always like to go ahead and check and see if we have a stretch or compress. If I'm looking at this, it goes over 1 up 1, over 4 up 2, over 9 up 3. Do I have the same pattern here? Over 1 up 1? Yes. Over 1, 2, 3, 4 up 2? Yes. So those are on the same path. So there is no vertical stretch or compress. Let's just see which way it moves. It moves 1, 2, 3 to the right, and 1, 2, 3, 4, 5 up. So 3 to the right and 5 up. So if I also write this as an equation, I would have the 3 to the right would be x minus 3, and the 5 up would be plus 5, like that. So when I'm writing in terms of f of x, instead of writing this square root, I'm just going to say f of x, and what's happening to the x inside, anything on the inside changes, goes in my parentheses, and anything outside we add to the end. If it's a vertical, if a stretch or compression is included, you put those in front of the f or in front of the x. I'm going to skip this one. There is a reflection across the x-axis, which means you can put a negative in front of the f or a negative in front of the x, depending on which one is appropriate. Let's look at g of x. G of x. What is happening here? Let's first check and see if we have any type of compression or stretch. So I'm going to go a different direction, so I know there's a reflection somewhere. Let's check the pattern. 1 over 2 up. That's interesting. 1, where's it? 1, 2, 3, 4. 1, 2, 3, 4. Oh, so this is 2, this is 4, now it's supposed to be 2, now it's 1. So everything's about 2 times higher than it should be. So that means we have a vertical stretch by 2. So vertical stretch by 2. It is reflected. Which way is it reflected? Reflected across the y or the x. This is going across the y. And do we move? No, it starts at the origin. So it starts at the origin and goes that way. So how do we make those changes? Reflection across the y. So if it is a left and right change, that happens inside, and the vertical stretch happens outside. So f of x, but that x is going to have to be a negative because it reflects across. That's how it goes this way. Inside changes left and right, and outside we need this vertical stretch because it gets steeper. So 2 f of negative x. Here's another one here. Doesn't look like there's any stretch or compression, but it is reflected somewhere and shifted. So it's reflected and shifted. Alright, number 5. Write an equation for square root functions with the following domains and ranges. Okay, let's make a little stretch for the first one. So if I had a coordinate grid, domain means it's going to come from the left. See, it's negative infinity to 3. So it's going to come and finish somewhere over here on the right side. And range is coming from up here. So it's going to have to come this way. Coming from negative, I'm talking about left and right, ending at 3, and my range is above 0. So what's happening here is we have an equation, y equals, I don't care about vertical stretching compressions, but it is being shifted 3 to the right, x minus 3, and not up and down. So that would be the equation for that. You could add any number in front to stretch and compress it. It wouldn't change it. Wouldn't change the domain or range. Remember, stretches and compressions don't change your domain or range. Next one, let's make a sketch. So this is going to start at -1 somewhere and go to the right to infinity. That's what domain says. And my range is 4 to infinity, so that's going to be going up. So it's up here at 4. So it's going to be going up like that. So my equation, again, I don't care about stretching and compressing because it doesn't change domain or range. My domain, inside change, it's going to be shifted to the left, which means x plus 1, and then it is shifted to the right one. Shifted to the left, shifted up. Let y'all finish that last one off. 6. The table below represents a few points from a function f of x. Fill in the blank table to the right to represent the inverse of the given function. Alright, inverse, we switch f of x, x and y. This is my x, this is my y. So I switch these, so I have -1, 3, 5, 9, -2, 0, 1, 3. My original function here, well, let's see what's happening. Let me pause this. Okay, this is a linear equation. Well, so this other one will be a linear equation. Let's get an idea what this will look like. Wish I had graph paper. So -2, 1, 2. -1 is 1 point. Next one is 0, 3. 1, 2, 3. 1, 5, 3, 9. 1, 2, 3, 4. And there's my line right there. To get my line, I need my slope. What's my slope? So from one point to the next, I'm going to use the closest ones here. This goes 1, this goes 2. So 2 over 1, my slope is 2. So y equals 2x. And my y-intercept here is 0, 3. Plus 3. Inverse function. Go ahead and make a little sketch of the inverse function. You know what? I'm going to use this one up here. Y'all see that? To draw the inverse function on this graph up here. So it has -1, -2, -1, -2. It has 3, 0. It has 5, 1. And then it has 9, 3. Right there. So there's that function. The slope of this, down 1, left 1, so -1/2. -1/2 would be get to this point, and it'll be halfway in between that. So the y-intercept would be -1.5, and my slope is -1/2. So -1 over 2x minus 1.5. Alright, since it's linear functions, domain for linear functions and range of linear functions are all real numbers. I don't know why that would be on here. Seven, 8, and 9. Use a description to write the square root function g of x and to determine its domain and range. The parent function is reflected across the y-axis. So it's reflected across the y-axis, this one. It's going to change left and right. So it's going to open to the left and stretch vertically by 6. So it means it's going to be real steep like that. So it's going to be stretched by 6, and inside we're going to reflect it. My domain is going to be negative infinity to 0, and my range is going to be 0 to infinity. Next one, number 8. The parent function is reflected across the x-axis. So x-axis is this one. That's a vertical change. That's going to happen outside. And translated 4 units to the right. That's again x value, so it's going to change inside. So x plus 4 inside is opposite. So right would be, that is supposed to go left. Negative the square root of x minus 4, like that. Domain, so since we're reflected across the x, it's going down, doesn't change there. But since it's translated to the right, my domain is going to start at positive 4 and go to infinity. My range, since it's reflected across the x, is going to come from the bottom. It's going to come from, it's going to look like this down here somehow. It's going to come from negative infinity and go to 0 because it's not moved up or down. I'll let y'all do number 9. Alright, I'm going to go ahead and finish this whole video, this whole review in one video. It's short enough to do that. Find the inverse of each function using a graph and table. Graph and table sounds like I'm going to grab a calculator right now. Alright, first one, find the inverse. Alright, so clear off my calculator. I'm going to say x plus 7, and there's my graph. And let's look at my table. Table right here is going to be 0, 7, let's see. Why don't we just find these algebraically? Let's go ahead and find these algebraically. That'll be easier. So this is y equals x plus 7. Switch the x and the y. X equals y plus 7. So I'm going to subtract 7. Subtract 7. X minus 7 equals y. There's my inverse function. Number 11. Same thing. This is my y. Let's switch x and y. So I have x is equal to 3 y squared plus 1. Subtract 1 from both sides. X minus 1 equals 3y squared. Then we got to divide by 3. Divide by 3. So I have x minus 1 over 3 is equal to y squared, and then I have to take the square root. Square root there, square root there. So y would be equal to the square root of x minus 1 over 3. That'll be good enough. You could also simplify this in here. This is perfectly fine. That's not option though. It could be y equals the square root of 1/3 x minus 1. Pull that 1/3 in the front. That would work as well. Alright, and the last one here, go ahead and switch x and y. Actually, I'll let you all do that one on your own. Gotta have something for y'all to do for tomorrow for extra points. Are the following inverses yes or no? Let's just go ahead and you can see if they reflect across the linear parent function, which it appears they do, but let's confirm it. Let's find a point over here. So this point is negative 2, 3. So we should have a point of 3. Wait, what is it? This is -2, 3, so we should have 3, -2, and we do. We have a point right here which is -5, 4, so 4, -5, 4, -5, that matches. Let's try one over here. This is 7, 0, so 0, 7, they all match. That is an inverse. Let's look at this one. This one does not look like an inverse. Let's check it. So, good point right here. This is 1, 3, so we should have 3, 1. Well, that didn't match. We have 5, 5, 5, 5, so that didn't hit that one either. So this is not an inverse. Alright, y'all can do the last one on your own. Given the graphs of discrete functions, F lists 2 points that are contained in the inverses. Okay. 2 points contained in the inverses. So this point right here is 36, so we'll have a point 6, 30. And this point right here is 35, 8, so we'd have 8, 35. Sorry, now you can see it. Y'all can do that one on your own. 3 things you know about the square root function. On my board to the left right here is the square root function. A couple things you can talk about are the domain or range. I told you earlier in the video what domain and range are always going to be for the parent function. Yeah, I'll let y'all do that one on your own. Graph the following, restrict the domain. Alright. Graph the inverse of the following, restrict the domain. We're restricting the domain because this is a quadratic, and if we do the inverse, it looks like this, and that's not a function. More of a cent sign. Alright, so we're going to graph this. So let's go ahead and, well, let's just switch them algebraically. I think that's the easiest way. Or you can put that in the calculator and find points. Let's do that. Let's just put it in the calculator and find points. So in the calculator, y equals, clear it, x minus 1 squared plus 2. And let's go to the table. So let's switch them all. This graphs, I'm going to sketch a basic idea of where this graph is, and then we'll switch the domains. Okay. At 1, something happens here. At 1, this is shifted to the right one. At 1, we get the vertex. So let's graph that vertex. 1, 2. And look, 1, 2, there's my vertex. 1, 2, that's my vertex. Then I have 0, 3. Not 0, 3. 2, 3. 3, 6. 4, 5, 6. And then 4, 11. Which I can't graph on the page. So those are the only ones I could fit on here for this one. So what I'm going to do for my inverse is I'm simply going to graph this right side from my vertex to the positive side. That's all I want to graph for the inverse. So I'll take this point. This point is 1, 2. So I go to 2, 2, 1. This point right here, so I got that one. This point is 2, 3, so I'm going to go to 3, 2. And this point over here is, what was this one? 4, 6. So I go to 6. What is that? 6, 3. There's my function right there. And just to make sure, is it reflected across here? It looks like those reflected. And that's it.